Dear students, in last class we have discussed the generating voltmeter used for measurement of high voltage. In today's class we will discuss spear gap used for measurement of high voltage. Spear gap is one of the standard methods to measure the peak value of AC voltage, peak value of DC voltage and impulse voltage. Here what you see is the arrangement of spear gap instrument used for measurement of high voltage. These shaded circles represent the spears supported by insulating material. The rods that you see here are made up of conducting material and they are called as the spear shanks. D is diameter of the spear. Both spears will be having same diameter. S is the spacing between two spears here, and that will be less than or equal to half of the diameter of the spear. P is the point at which the sparking takes place. Here you can see radius B, and this radius B is of a spear around the two small spears, and that spear having diameter of B is called as clearance spear. Within this clearance spear there should not be any earthed objects, because if any object comes within this spear then it will have effect on the breakdown voltage of this spark gap. You can see here insulator support. The top spear is supported by the insulator support. To the shank of the top spear, high voltage is applied. The low voltage spear is earthed. The structure here on which the lower spear is mounted will be having operating gear and motor for changing the gap distance. That is, by operating the motor inside here, we can move this lower spear up and down so that the distance between the spear is adjusted. We shall have to adjust the distance between the spear according to the range of voltage that is to be measured, or the magnitude of the voltage that is to be measured. You can see here certain plane X. High voltage lead should not pass through this plane within the distance from P to B. The two spears shown here may be placed horizontally also. When the two spears are placed horizontally, one spear may be connected to the high voltage source and the other spear may be grounded, or both the spears may be connected to the terminals of high voltage source. A is the height at which the sparking point should be maintained from the ground. When this spear gap instrument is used for measurement of the high voltage, the potential difference which causes the spark over depends on size of spears, dielectric strength of the air, distance between the spears, humidity and temperature of the air. The potential difference which causes the spark over depends upon the size of spears, the distance between the spears, dielectric strength of the air, humidity and temperature of the air. Spear gap construction and assembly. The spear gaps are made with two identical diameters D with their shanks. Operating gear and insulator supports. Spears are generally made of copper, brass, or aluminum. The latter is used due to low cost. The standard diameters. For the spears are 2, 5, 6.25, 10, 12.5, 15, 25, 50, 75, 100, 150 and 200 centimeter. The spacing is so designed and chosen that the flashover occurs near the spark point P or at the spark point P. The spears are carefully designed and fabricated so that their surfaces are smooth and curvature is uniform. The surface of sphere must be free from dust, grease, or any other coating. The surface must not be polished while cleaning. For measurement of voltages, less than 50 kV, the spear gap needs to be exposed to X-ray or quartz tube mercury vapor lamp radiations in order to ionize the air. See, if the spear gap is not exposed to X-ray or quartz tube mercury vapor lamp radiations, in that case the spark over will not occur, because 50 kilovolt or less than 50 kilovolt voltage is unable to ionize the air between the spheres, and hence such voltages cannot be measured. For that purpose only the spear gap should be exposed to X-ray or quartz tube mercury vapor lamp radiations, and this process is called irradiation. The spheres may be mounted vertically or horizontally. when spheres are mounted vertically, top, which is fixed sphere, is supplied with HV and bottom sphere which is movable is earthed. When spheres are mounted horizontally, fixed sphere and movable sphere are connected across HV source or movable sphere is earthed. And fixed sphere is connected to high voltage source. To limit the current, drawn from HV source during spark over a series high resistance is used. Now we will see how we can measure the high voltage using this instrument. The table here gives us the ready chart which can be used for measurement of high voltages. For width, the spear gap instrument having spears of different diameters and different the gap spacing in centimeters. So just before referring to this table, let us read this. Peak value of spark over voltage in kV for AC, DC voltages of either polarity, that means positive or negative, and for full negative standard impulse voltages with one sphere earthed. A and positive polarity impulse voltages and impulse voltages with long tails. B at temperature 25 degrees Celsius and pressure 760 torr. Now 17.4 here is peak value of spark over voltage in kV for AC DC voltages of either polarity and for full negative standard impulse voltage with one sphere earthed and the two spheres having a diameter of 5 cm with a gap between the two spheres 0.5 cm. Also, if you look in the column B, 17.4 tells us the peak value of spark over voltage in kV for the positive polarity impulse voltages and impulse voltages with long tails. Long tails means the tail length of the impulse voltage should be more than 5 microsecond, and these values are valid only for a temperature of 25 degrees Celsius and pressure 760 torr. If you refer to some other columns, say for example, when the two spheres have 25 centimeter diameter, then with a gap of 1 centimeter between the two spheres, 31.2 is the peak value of spark over voltage in kV for AC DC voltages of either polarity and for full negative standard impulse voltages with one sphere earthed. Whereas for the same diameter and for the same gap, 31.4, you see the difference here, it is 31.2 and it is 31.4 kV peak value of spark over voltage in kV for a positive polarity impulse voltage and impulse voltages with long tails at temperature of 25 degrees Celsius and pressure 760 torr. So while measuring the high voltages using sphere gap arrangement, we have to refer to this table. If there happens to be decrease in the ambient temperature where the sphere gap instrument is placed, then the breakdown voltage or the spark over voltage will slightly increase. That we can see in the next table. Now this table is for 20 degrees Celsius, whereas previous table was for 25 degrees Celsius, and here also the pressure is 760 torr. So when diameter of the sphere is 5 centimeter and the gap between the two spheres is 0.5 centimeter, the spark over voltage has slightly increased and it has become now 17.5 instead of 17.4 kV. This point is also very important because we need accurate spark over voltages For spacings less than 0.5 D, the accuracy is plus or minus 3%, and for spacing greater than or equal to 0.5 D, the accuracy is plus or minus 5%, which means that with a spacing of 0.5 D, if I measure the spark over peak voltage value as 100 kV, then the spark over voltage peak value may be 97 kV or it may be 103 kV. Similarly, we can make the calculations here also. Now we will look at advantages and disadvantages of this instrument. Advantages: first one is cheap, simple in construction. Second one, simple in construction as well as usage. Third one is reliability. The measurements made using this instrument are highly reliable. Fourth one, this instrument can be used for measurement of peak voltages of value ranging from 2 kV to 2500 kV. Fifth one, calibration of high voltage voltmeter and voltage measuring devices can be done easily. So this setup can be used for calibrating the other high voltage measuring instruments. Sixth one, impulse voltages of either polarity can be measured. It is not necessary that the impulse voltage under measurement must be of positive polarity or negative polarity. It may be of any polarity, we can measure it. Next we will see the disadvantages of spear gap instrument. It does not provide the continuous record of voltage. It is so because spark over is a very short duration process. Also, we must remember if we need to measure RMS value of the voltage, then we have to multiply the measured value with root 2. We'll write here one more disadvantage, that is this setup cannot be used for measurement of impulse voltages with front time less than or equal to 0.5 microsecond and tail time less than or equal to 5 microsecond. Measurement of HV at temperature T and pressure P. If we know the spark core voltage peak value at 20 degrees Celsius and 760 torr. Let us call this voltage as V0 here. Then measured voltage at pressure P and temperature T, that is V, is given by K into V0, where K is the function of D, the air density. That is D equal to P by 760 into the bracket 293 upon 273 plus T. Knowing P and capital T, we can calculate the D value, and if we calculate the D value, then we can know the value of K referring to the chart that I am going to show you now. So here is the chart to which we have to refer to know the value of K. So when we calculate the value of D by using the value of P and T as 0.70, then the corresponding value of K is 0.72, and this we have to make use to calculate the spark core peak value of the voltage capital V using in this equation. Dear students, I will stop the class here and continue in next class. Thank you.